Hi chaps, it's a while since I've done an electronics video, so this is the first one for a wee while, and today we're messing around with another pantry transmitter. Now, as we can see, we have an Arduino in here, right, and it's a bit lashed up, it's hanging, and it's just a test. And what it is it's one of the guys on YouTube, which I will put a link onto it when I upload this video, has come up with this Arduino AM transmitter. Now, there were some exceptions to his video that I have to say that I didn't necessarily agree with. What he was doing was he had a ferrite rod antenna, and he was using the main winding of the ferrite rod antenna with a series capacitors or a tuning capacitor. Personally, I don't think that's the right way to do it. The impedance of the oscillators in the Arduino is low. So what we've done in this case is the two oscillators that it's using, we're using a few turns round the ferrite rod antenna and back into the relative connections on the Arduino, which is pins 3 and 11. I've got a 47 picofarad capacitor in series with it, and of course we're using the main winding to tune it. Right, this thing is full of harmonics. It's square waves, as we know, but we don't want that. We have to filter it out, and we filter it out basically with this tuned circuit. We could do it with a pi tank coil, which would probably be even more efficient, but I decided just to do it this way because I'm radiating the signal from the ferrite rod. Right. I haven't done all the usual tests that we're supposed to do on this, the trapezium and so on and so forth. I haven't got round to that. I've done audio checks with the ears and of course with the scope. I'm afraid that we've got the usual flashing. I wonder if I can change that at all. There you go, that might be a wee bit better. We're actually approaching about, in fact we're over 100% modulation here. We're driving it from the PC, which is under the bench, into the monitor and the headphone socket out into the Arduino. Right. I'll put it on. Now we are actually well and truly overdriving this too much. I'll knock it back a bit. That's better, I think. This is the tuning. Now this is me adjusting the tuning. As you can watch the magic eye. Actually, I don't know whether this is the best of tracks for this right enough. Let's see what else we can put on. We'll come off that, we'll go back onto computer and we'll see what else we've got here. I don't want to fall foul of the copyright folk out there. Have we got Floyd Kramer, eh? Sounds alright. Back to the scope. Okay, we'll open it up. There we go, there's the RF with the modulation on it, obviously. So we don't have square waves coming out of it. It's actually pretty good. Now it's just adjusted tuning. Even off, it's pretty decent looking. Not a lot wrong with that. Range is good. Shall we go for a walk? A lot of noise here. Christmas lights and things. This noise is not coming from the Arduino. There you go, still there. And that's the distance we're away from the shed. So, from the peak. Now, what you could do, of course, is we could build a pi tank, like I've already suggested. Build a pi tank coil for this, and you would actually probably have a better overall result. You'll be able to filter out some of the harmonics, and don't forget there's loads of them because we're talking about a square wave output. So yeah, a pi tank would be the best, and then of course onto an external antenna. But if you want to feed your pile of valve radios from this, it will work fine. And I do believe that the modifications that I've done to the circuit actually improve the results. When I initially did this, I did it the way he did it. I was not impressed. It was only going maybe about 2 or 3 feet. It was a bit distorted as well, so I don't think the filtering was particularly good. So the way I've done it is better. Now, like I say, the coupling from the Arduino up to the small coupling coil here is via a 47 picofarad capacitor. Now, in fact, if you increase the value of that to likes of 1000 picofarad, the range goes up quite a lot. There's quite a lot more output from it. But I didn't really particularly want to think about range rather than audio quality. Actually, slightly worse quality, but it's really hard to tell the difference, to be honest. But that's one of the reasons why I want to do the rest of the tests on this at some other time. This was a project. This I used to have the little 2-valve Russian rod pentode TRF in this, but with the demise of the medium wave stations, there wasn't an awful lot of point in doing that, and this was just a rough winding of some Litz wire. I'm going to improve that as well, and tidy it all up, and also mount the Arduino in this and have the battery pack up the back. Have the battery back in this here, have a power switch, etc. Tidy it all up, make it look more like the thing, have the jack socket on here, etc. So there is a bit to do with this. Is just the initial test of it to see how well it works, and I have to say I am quite impressed. I mean, I've made a number of low power pantry transmitters over the years using either an EH90 or the mini mod. I've even had the bot ones as well. Had a couple of them. Again, I wasn't hugely impressed. They work, but they're okay. But this, in fact, for what it does, is okay. There is a tiny amount of artifacts in the background, as you can hear, but the volume's way up there. You know, it's quite loud. I mean, this thing only needs a tiny amount of control on it. Let's put another track on. In fact, let's get something else. I may as well do it right and really get into trouble from YouTube today. So, it's not so much who cares, but it can be a wee bit of a nuisance actually when they go on the way they do. Especially when you're not really doing it to demonstrate anything other than a project. And well, let's say, we'll go back a bit. We'll go back to 1962. I think that's as good as anything. As I say, there's only a tiny bit of volume in there. See if we're over modulating or not. we'll pause it at that. I mean, you can hear the noise in the background, but it's very low, and I'm sure, to be quite honest, with a bit more fettling with the circuitry, we could actually improve on that. I'm certain we could. In fact, if I tune it, I can actually tune it more or less out. So it's all down to filtering. So if the filtering can be a wee bit sharper, I think, to be honest with you, it would work even better than it is at the moment. So maybe a point to take into account, that if we do improve the filtering of the circuitry, I think you'll find that it'll be much better. So as I say, this is just a lash up. This is just a small test on it to see what it's like, and it seems to be okay. So I don't have an issue with it. That track tends to be a wee bit on the low side of HF. See if we can let you see that. I think, to be honest, the other thing right now is, hang on, I think the other thing, of course, in fact, the issue here is I'm probably overdriving it a bit with the audio. I've got the computer under here, and I've gone into this monitor. The computer's just a bit flat out, as is the monitor. Now that could easily be changed, because he has put an attenuator on it, and it's basically his circuitry here that I'm using, and there is about 50% attenuation from the original signal, so I don't think it needs as much as that. So what we've got is, well, I've actually got a bit more, because what I did is I've got the audio coming into the jack socket, and I've got two 1K resistors coming off that, and then there's a potential divider here, which is 1K and 1K to ground. So there is a bit of attenuation there, probably a bit more than that we really need, to be honest, so that we can fiddle about with the values. Might be in actual fact better to put a volume control in it rather than have the potential divider as it is. So that might be something that I'll do, is make one of these old controls here a volume control. Well, yeah, I mean, I'm convinced I'm going to leave it the way with this. I might go down the pi tank route, but this is actually quite good. It means I don't need to use antennas, long wires, or anything like that, bits of wire. It works quite well with the ferrite, and as you can see, using the Roberts, we could pick it up right at the back of the house. So there you go. I thought I'd let you see it. A great wee project to make. Audio quality is lovely. It's really good. The range is excellent considering what we have. And it's a cheap enough device. I've done it on one of the older Arduino Unos with the chip on it. I also tried it on with the surface mount, and it works just as well. So there you go. Okay, guys, I'll put a link in the what do you call it, in the comments, as to description, I should say, as to where you will see the original. And thank you very much to the original designer of this, and hope you don't mind that I made one or two small improvements to it as well. I also find the circuitry as well for the original project as well, and I shall link to the two that is there. Okay, thanks guys, all the best, take care, and Happy New Year when it comes. Bye for now.